A young German physician working in complete isolation from the scientific community of his day went to Berlin and gave a lecture to a very small group of other physicians. One of the physicians that was there went home and later recollected that evening lecture, and I quote from his journal entry. "I hold that evening to be the most important experience of my scientific life." The name of the physician that gave the lecture was Robert Koch, who went on to win the Nobel Prize in medicine and completely change our lives. Many of us, perhaps most of us, are only alive today because of what that man did. The physician who attended the lecture and wrote in his journal's name was Paul Ehrlich, who later went on to win the Nobel Prize in medicine and became universally recognized as the father of immunology. Today, the great-great-grandnephew of Paul Ehrlich, Garth Ehrlich, is here today to turn the world of Robert Koch upside down. So I hope the historical irony of today's lecture is not lost on anyone. I've asked Garth to come here and give a relatively rigorous explanation of his distributed genome hypothesis, because our specialty, the entire edifice of endodontics, is based upon what Robert Koch did. And everything that we do goes back to that. And if that edifice is under attack, then as endodontists, I think we better know something about it. So I've asked him to come and give this explanation of how our world is about to be turned upside down, and if nothing else, we will confirm the old saw that the apple does not fall far from the tree. Garth? I would have reprinted his CV, but it's 92 pages long. He's one of the most accomplished scientists I've ever met in my entire life, so I know you're going to really enjoy his presentation.
Gary, thank you for that incredible introduction. So we heard from Dr. Bate about the importance of mutation and the difference between life which replicates with mutation versus crystals which replicate perfectly. And so what I'm going to be talking about today is the importance of mutational mechanisms in the evolution of bacteria. And what I want to, if you leave with nothing else, is to understand that during the chronic infectious process, one of the things that allows for persistence over time in a patient is the fact that the bacteria are actually changing during the infection. And so it's their ability to mutate during the infectious process which leads to persistence. So let me just start with some simple definitions that we use so that everybody's on the same page. Genetic heterogeneity means that there are different alleles of the same gene present among individuals of a population or a species, and this is what most of us are familiar with who had a basic course in genetics at some point. What I'm going to be talking about more today than genetic heterogeneity is what we call genomic plasticity. And this is very different. It says that there are different genes present among individuals of a population or a species, such that all individuals of the same species do not have the same set of genes. Now this, we as we go through the lecture today, we'll find that this is pretty much universal for prokaryotic organisms, at least for bacteria. We haven't looked that much at archaea yet. And it may apply to some asexual eukaryotes, but any organisms that go through sexual reproduction you're not going to find this type of genomic plasticity. And so as Gary was saying, we as microbiologists, and particularly microbiologists who study infectious disease, we all owe an enormous debt to Robert Koch. And his paradigms were developed to explain what were the prevailing infectious diseases of the time. These were acute clonal epidemic diseases that would run through populations and kill very large segments of the population. And the system that he came up with very accurately modeled what was going on in these acute infections. And so the idea, of isolating, a single bacterial isolate, putting it in culture, taking it out, putting it in an experimental animal, showing it caused the same disease, and then re-isolating it, was a very valid and paradigm, and it still is if you're dealing with acute clonal infections. What I really want to stress today is that there is a fundamental difference between acute infections and chronic infections, and Koch's postulates don't apply to chronic infections.